But we spoke yesterday about the subject for this this conference, public health and sustainable construction. So I just threw in another project to start out with that in many ways shows how we deal with these issues as architects. You know, we're not sort of specialized and go very much into like how can we sort of address issues by BIM or by technical components and so on. It's more at the general level that we show how we improve life for people. I think we could say that in terms of sustainability and so on, I think architects has always been very sustainable. I mean, that's basically what we do. We try to improve the life for people. We try to make optimized systems, try to reduce the materials and the energy and so on. So I think that from an architectural perspective, sustainability is actually our core business. I'd like to start with a project not really related to facades, even though it was a huge facade job. So what I like to present on this project is not really the facade, but more the attitude about talking about public health and livability. And you probably have seen it, but this building almost finalized now. The facade has been executed by Cipral, and basically the reason why I'm here today, due to Leopold Bares. But this project is a new waste-to-energy plant in Copenhagen. In Denmark, we have a long tradition for burning waste and getting hot water and electricity out of the waste. And 25% of the energy for Copenhagen is coming from the current waste-to-energy plant. So 8 years ago, the city of Copenhagen decided to replace the old plant. And one of the first issues that had to investigate was the actual location. And they decided to keep the current location. I just have to see this one, where you see that this is the city of Copenhagen. In the middle, you see the old city center. Oh, I'm not sure what happened. Okay, good. So you see in the middle here the old city center with the Queen's Castle, and we had the most important buildings like the harbor here, the opera and stuff. And in this location, in this old, you can say very large harbor area, in this location we have the current waste-to-energy plant and also some big energy plants. And it was a very crucial decision to decide whether to move this plant, the new plant, to the outside of the city or actually keep the location. And due to some heavy investments in the infrastructure, they finally decided to keep the location, but at the same time they decided that this should not just be an industrial plant, but to be something very special. So they made a competition which we won, and we took the opportunity to investigate how you can actually utilize industrial plants and cities, not just to be sort of for the main purpose, but how they could actually bring something back to the city and be part of the city life. And we thought that this whole circle about taking the waste and making it into energy and giving it back to the city, this whole circle we thought was very interesting. So usually these plants are just like simple boxes. So by some geometrical exercises where we tweak the shape, move the machinery a little bit about, we turned this very large volume, it's actually the biggest volume in Copenhagen, into this more leisure area. So the idea was to use or utilize the roofscape for a roof, or sorry, a ski slope, combined with some green areas and a roof park. You can see that the location of the building is at the proximity of the city center. We have these, this is a boat, what do you call a harbor for leisure boating just next to it. And we have, yeah, and you see that we sort of combine these, the proximity to the green areas with extending the green areas of the park on top of the waste plant. And I think that this section is very fascinating to show that normally all this machinery, no one really knows what it is, but in this case we expose it. You can move, when you move to the top of the building, you move in a glass elevator, so the citizen of Copenhagen that wants to go to the top and utilize this roof park will have an idea of what is going on and how you see the whole process of the waste. The waste-to-energy plant is in that way sort of converted, you could say, into a more public space, to a leisure park. We have this ski center area in front of the main building, where you can see sort of leisure facilities. And here you see how you from the front here, then you move up on this ramp, this green ramp, and you see all the people here, and then you can move up and walk all the way up to the top of the building, which is sort of 100 meter tall. At some point, the waste-to-energy plant actually complained a little bit about that more or less no one really says, now they don't talk about the waste plant with the ski slope, now they talk about the ski slope with the waste plant inside. So for the citizen of Copenhagen, I mean, everyone knows about this project. Everyone talks about waste to energy, because this idea of this ski slope has really sort of hit the press and hit the mind of normal people. We also install, I think it should be sort of Europe's tallest climbing wall. You can see this is a very, very early sketch, but we are going to do a 90-meter tall climbing wall on the facade. So this is also a way, you could say, of not just doing a very expensive facade for the cladding of an industrial building, but then try to investigate how can we actually utilize this huge facade for something for the public. And here you see sort of the layout of the roofscape. We have sort of green areas, park areas with trees on the side. We have the red stripe sort of marking the ski lift, where you can sort of move up and then you can ski down. It's supposed to be for everyone, for kids, for elderly people, for skiing people, but generally it should be sort of a park area for everyone. At the top, of course, we have this cafeteria area where you can then sort of sit and enjoy the view of Copenhagen. And maybe you can't see in this picture, but we had the sea in Sweden at the background here. This is sort of the layout of the different ski slopes. So this is sort of saying how we as architects address, you could say, public health. I mean, public health is very often sort of considered at a technical level as ventilation systems and energy ideas and so on. But we think that for us, public health goes much broader. It's about bringing quality to life, living in a city. And this is the current state of the building. This is a real photo, so you can see that the facade is up, the chimney is up, and I think in 3 weeks they start to burn real waste in the plant. And we expect to open the ski slope in 2018, summer 2018. So back to more sort of related to facades in this context. I think that the current facades, or the way we struggle with facades nowadays, we try to summarize and saying what is actually development. You can see that in some cases architecture has developed a lot. In some cases it's a really slow exercise. We don't advance in our technology as they do in airplane technology or car technology. It's a very slow technology. And you can see that basically this is sort of 4,000 years of development. We sort of started out with some very simple volumes, not transparent, but heavy stone volumes. And now this is not our project, but just to exemplify how we sort of move back and still are working with these simple forms. But now, instead of sort of being solid, we sort of have it into more sort of transparent, or actually total transparent finishes. And I think that this result, I mean, this example you see here is also the basic for all our struggles, also in terms of public health inside our building. This is another example going from, sort of, you can see these simple circular buildings, and then we see this is from Oxford, Herzog de Meuron. Still sort of these basic forms, but now move from sort of solid walls into fully glazed walls. During sort of 600, 700, 800 years, we saw that facades, I mean, glass were only sort of became common in architecture in the 17th century. It's very late that it sort of became a normal thing to use. We have a little bit of glass in these buildings. So basically for 600 years, the exercise of facade design was still like sort of heavy stone walls with punched windows. And then the architects sort of very artistically articulated the interface between the punched walls and the stone surfaces. And at some point, you can see that this is where we start to see sort of the early curtain walls, but it's still very rare. And then we move more and more into more and more glass. And of course, it's because the glass industry is developing a lot. You can get glass; it's cheap, and you can actually start to use it. And of course, everyone is sort of driving for getting more and more natural daylight to get deeper into to the buildings. And this is sort of the result where we end up before last century, where we see now we can use a lot of glass, but the architecture is still based on old classical architecture. And you could say that with the modern world, that led for, or asked for, a lot of disruption. That now architects were desperate to find a sort of more modern language to exploit all the new technologies and the use of glass and so on. And finally sort of led to this. This is what we all know. And this is actually the legacy that we are working with now. Not a lot has happened since the modern movement came into our life in the early 20s. And you can see, compared to, I mean, those kind of exercises, this is a totally new form. So what also happened at this point is that up till that, architects has been trained to lay out facades, to make 2D drawings, nicely laid out at these points, windows. But now we moved architecture more into like objects. And architects more or less during the last 100 years, more or less sort of lost the ability of just drawing a simple or nice facade in a street. So what we turned into was really like volumes and skins. And you can see this is sort of the result, where now it's not like, now it's volumes we're working with. And volumes are very difficult. Yes, you can make some volumetric studies, but to, you can say, to advance these volumes with punch windows are actually quite difficult for architects. So this is sort of the normal thing for architects to work with. This is what we can work with. And in terms of health and safety and facades, we move from these solid walls with punched holes, and now we moved into frames, skin systems, but basically fully glazed. And of course, this is also the entire struggle. And the reason why we moved into the skin is because this is what architects now like to see. We like to see open floors, and you can see in this render, this is a typical render from our studio, from the competition states, that you see fully glazed floor-to-ceiling facades, no mullions, no nothing. And of course, the glass is totally clear. No tinting, no solar shading, no nothing. This is basically how we always present our designs, because this is what architects really try to achieve, or most architects try to achieve. And of course, it's leading to this kind of buildings. We all know these kind of buildings with a fully glazed skin. You don't see any exterior solar shading. You see a little bit of curtains maybe inside, but this is how we like to present it. And of course, still you see full, very clear glass all the ways. So what are we doing? It's basically about shading. It's the constant struggle we're doing. After we sort of win these competitions, and now we have to make it into a full design, then we have the energy engineers, we have to develop stuff, and the first thing is, of course, how do we control energy? And in our part of the world, in the Northern Europe, of course, solar gain or energy gain from solar shading is the big thing. And it's not very advanced. We still work with these sort of more or less basic four principles, that either we can sort of turn the building so we have the glass to the north, we can include some exterior shading, some interior shading, it's not as good as the exterior, or we can work with the glass coatings. And I think that while we're sort of developing these basic rules, we are still waiting for the glass industry to basically solve our problem and come with this, with a miracle, and finally have this totally clear glass that can just solve all problems. I just want to show you some projects where I can sort of exemplify how we sort of install these different concepts. The architecture might look, of course, it's sort of very dramatic. It's a very spectacular architecture, but the principles of the facades are actually quite still basic. This is the new energy headquarters in Shenzhen for Shenzhen Energy Company. And of course, Shenzhen is located quite south, so solar gain and glare issues are, of course, a big issue for this building. So you can see that we sort of work with these very vertical lines in the facade. We have some large openings, but these large openings are all oriented to the north. So you can see that from this is a picture from the north angle, and here you can start to see a lot of glazed area. But when the facade starts to twist, then it gets more opaque because of this the layout or the geometry of the facade. I'll just show you in the next slide here. So this is sort of the same. So you can start to see all these vertical panels running down the facade. And the system is very, very basic. That you see that we have this cladding where we orient the glass. So the sun coming straight from the south and from east and west, of course, is sort of blocked by these panels, and then the glass is sort of oriented, so you basically only get the northern light. This is sort of two images where you can see that you see this image is more directed to the south, where the view is blocked and also blocking the sun. But then you turn, and then you have basically the full view over the city. But of course, more directed to the north. So in that sense, we can have clear glass. We don't have any either exterior or interior solar shading, and we can control the indoor climate. We have very spacious places, and we talk about public health and the environment. This is our architecture, very much based like this. High seal spacing, including greenery, and introducing a lot of openness, so you have the transparency in the buildings. This is from one of the big openings to the north, where you have these magnificent views over the city. This is another project we're working on currently, or we worked on it until 2 weeks ago. We're sort of at full stop. But this is in Israel, in the Middle East, and it's a new campus. It's a 100,000 square meter campus with offices and R&D facilities. So and it's just at the outskirts of Tel Aviv, in sort of industrial or office area. So you can see it's sort of located in this landscape situation. It's very large, and it's designed as this very compact volume, and then we carve out streets and plazas into this. And of course, the idea comes from sort of combining this landscape with this typical very dense cities that you see in the Middle East to protect from the sun, and then creating these more very private spaces with a lot of atmosphere, and then combined with the livability of Tel Aviv. And when you enter this massive block, then you get into these spaces that are covered by these very sort of cantilevered, double curved facades. So when you are at the plazas, you are cooled by, we have a lot of water sort of cooling the space, and of course the sun is blocked. The sun can only enter these the plazas through these quite narrow voids at the top. The whole campus idea, of course, is to create the idea of a city. So you see this transparentness where we have cafeterias, restaurants, and kindergartens, libraries, and so on. And we sort of continue this openness, this transparency into the building. So you have a very sort of clear connection between the interior space and the exterior space, and also to create this transparency to give people sort of walk in the plazas the understanding of what is going on in the buildings, instead of having usually you see in the Middle East these glass buildings with body tinted totally green glass, and no one knows what is actually going on. You also see that transparency, this void moving up through the building, so you have connectivity between the floors. Again, the solar shading concept is very basic here. So this would sort of be the normal facade, or you would say the normal facade in the Middle East is this body-tinted green glass, which we do not want. We want a totally clear glass. So another way to go, of course, is to install a lot of exterior solar shading. We moved to this idea to have deeper solar shading and less to keep the clear view. So you see that instead of having a view sort of split into to 4 small views, you actually have this very nice open view. And of course, the plazas in these double curved slope facades, we don't need anything because they're already shaded by the curvature of the building. So for the solar shading, we sort of developed 4 different types of exterior concrete panels cladding. So we have sort of the first module, which is sort of to the north, with basically no solar shading. We have 3 different panels with different depth, depending on the location on the facade and how much solar energy. And the gain, or what we needed to reach, was a 40% shading of the facade during the year. So, and on top of using it, then, which is one of our strategies a lot, is always to sort of exploit what can we also use the items for. So instead of just saying now we need the panels for the solar shading, then we include some greenery for the build-up, because we have the panels anyway. We include balconies and so on. And for the deepest one, we include both greenery and balconies. So the solar shading concept morph into also be an advantage for the users of the buildings. So instead of having, once again, these sort of very sealed office buildings that you see in the Middle East, you were able to open sliding doors, and on all floors you can just enter into the balconies. Here you see a combination of this sort of concept of the 3 different types of the facades. And here you can see that we sort of start to sort of understand. So what is the performance of the different panels we have? The different colors sort of indicating, of course, the shading factor. So we ran a lot of simulations on the buildings. This is also done in Grasshopper scripting, as was discussed before. So we basically asked the program, we put in some parameters, and then the computerized modeling will show us where we should distribute. So you could say that the architecture of the facade, we define some rules, and then basically the scripting will sort of define what is the actual layout. This also, as was discussed before with the BIM model, that during the process of course adjusting this very huge the massing of the campus, because we had it as a scripting, every time we sort of adjust the massing, the facades will be adjusted automatically. So we control, because it would be a disaster if we don't control the energy or shading factor, because the ventilation system, the cooling system, everything is sort of dimensioned based on these criteria. So here you sort of see some final results on, this is a south facade, so that will only have the deepest type of facade elements. This is sort of a north facade, and then you can see at the edge we still have some areas where we would need to have deeper balconies. Here you see some more technical drawings where you can see the sort of different build-ups from this is the very small one to the north, and then we move into deeper balconies for greenery. And this is the final result. where instead of seeing these sort of very corporate glazed buildings, at least I think that we sort of have a campus that is very inviting. We have greeneries, we have clear glass, so you can actually see people moving around, working in the environment, and you will also see people being on the balconies, having a smoke or whatever. So the building becomes sort of very inhabitable and inviting also for the public. The interior spaces, open spaces, floor to ceiling glass, and you have the proximity of the greenery just outside the windows. With this very sort of Scandinavian attitude of materials, which is very unusual in the Middle East. So I just move to the next project. This is the Tallinn Town Hall project in Estonia, so quite north located. Here again, you can see that it's a very large office building, 50,000 square meters, and of course both offices, but a lot of public spaces as well. And here again, the idea was to make the whole office complex very open to the public. Instead of sort of closing it, we thought that the town hall is actually a building for all the citizens, and we like to sort of exploit, or wanted to exploit to the full content, how we could actually bring the public and the city into the building. So you see that it's sort of split up. All the different departments for the municipality sort of have their own building. So this is sort of you could say the sort of normal way of sort of clustering an office building, and then we sort of move into this more like, you could say, actually a small town of the different departments, and then between those we can sort of include and having daylight and having looks into the sky, visual looks into the sky, and instead of having this sort of, you can say, very defined this very sort of a defined perimeter, the perimeter gets more porous and gets more sort of, you could say, actually accessible for people. In terms of daylight and sort of the interior environment, splitting the building up to all these small volumes also means that we can get daylight in between the voids, both direct daylight but also reflecting daylight. Due to constraints of height and the site and so on, the office spaces became quite deep. So we also introduced some roof lights somewhere that we had, where we could sort of redirect the light and move the light into it. But of course, difficult in terms of technically to solve it. The building is sort of located just outside the old city center of Tallinn, and the idea was to have the ground floor space completely open as a public space, so you could move from the city center, and then you could basically move through the building into this park area that will sort of link to, at the end of this park you have the sea, and you will have some boardwalks and so on. So the building would sort of be a point on a route combining the sea and the old city center. Here you see the result is sort of very open. Once again, this ongoing theme of transparency, of linking the spaces, making it clear so you can actually see people working, you understand what is going on in the building, and the building becomes very inviting for the public. Nothing is sort of concealed, everything is open and transparent, and greenery, of course, is included as a main theme in our studio. The greenery, we now have our own landscape department with 10 people, because greenery is always included in our buildings. And here you see this is from the council hall with its glazed, and you see a big mirror in the roof, so the people at the council can look up and see the city of Tallinn, and from the city of Tallinn you can actually look through the building, see this mirror, and then you can see the council work. Once again, to sort of bring this transparency, and for Estonia, you know, post-Soviet entity, it was very important to use this building to make this, you could say, sort of this democratic or process of democracy very close to the city and the citizens. for the facades, just to be specific, in this context, you can see we have these very, very deep office spaces. And the location, which is quite north, means that we have very low sun angles from west and from east, of course. In the morning, in the afternoon, we had it. So we had to sort of develop and work with different strategies. So for this building, we had an inverted closed cavity, or I wouldn't say closed, just a slim cavity double skin facade. So you see that we have the heavy glasses on the outside, and then we have the light glass on the inside, so we can open them up and we can clean. For the council hall, this is actually I think it's sort of 30-meter tall glass wall. We did also an inverted double skin facade where you can move in, so you can see that this facade is actually ventilated. So in that way, we could deal with the solar gain, and with you can see we have the Venetian blinds in the cavity. But of course, what was very, very difficult for us to work with was the daylight. We did not fully develop this system, but we worked with this sort of blind. Maybe some of you have worked with this, but the idea is that these blinds, you redirect the light very long, deep into the buildings. I think there is a lot of academic discussions going on if this system actually works. We didn't install it because the buildings was stopped, but this is definitely something that we have tried to develop further on in all the buildings, because if you can sort of block the sun at the lower part with different angles, and then you can redirect the sunlight at the upper parts, of course it means a lot to the health and the environment of building, but also energy-wise. I mean, what is of course strange nowadays is that first we sort of block all the daylight with coatings and exterior shadings, and then we turn on electrical light because we don't have enough light. And this is still the big dilemma with modern buildings with all this glass, is that something is really sort of contradicting all the time. The last project I want to show you here is a building that we are designing just currently in Amsterdam. And once again, you see that we have a lot of glass, and you see a lot of fully clear glass. And we really expect to develop the building with this fully clear glass. And you see there's no exterior sun shading at all. It's the overall volume sort of combination of sort of this, you could say, sort of low standard block and a more sort of, I wouldn't say high rise, but vertical block, and then we sort of transited into this shape where we install some roof terraces, and then we open up to the front with a small plaza. You can see here that this is a very trafficated area in Amsterdam, and by making this move, we sort of create this plaza, and then we connect to some park or green areas that the city will install around the building. On top here you see the roofscape with the open terraces and the greenery. The facades are quite spectacular. This sort of heavy pixelation where you see the glass going almost to the edges. You see these cantilevers all over. Of course, this cantilevered situation is blocking the sun on this is the west facade, so it's blocking the sun, but not fully. So this is not really doing the job in terms of energy or solar blocking. You see all these terraces, facades sort of cascading down. So I want to show you these drawings here. So you see that this is sort of floor to ceiling glass, totally clear. And to our luck, in Holland they have what they call the Dutch facade system. We sort of know it that they use internal blinds located behind the facade, and then they simply make a double skin facade, you could say, or they make a cavity between the glass and the interior curtain. And then they have an opening. You see here the ceiling is not going all the way to the wall, and then they simply suck the air out and use the cavity between the ceiling and the structure. They use it as a cavity to take out the air. We are working with a G factor of 0.27. It's interpane glasses that we work with. Beautiful glasses, by the way, very clear. And according to the local energy engineers, this works. We are quite skeptical how it can work. We have not seen a lot of documentation. I don't think there is a lot of academic work actually, or testing done on whether this works. But as long as the local M&E engineer or energy engineer is saying okay, of course we sort of continue with this facade system, and we think that this is very promising. Of course, for the interior curtains, we can work with different finishes. And we also now are looking into sort of glossy internal blinds that will be very reflective. And what will be very interesting to see for the future is the glass industry and sort of curtain industry sort of can collaborate, because now we're sort of working with two combined systems, or actually three combined systems, because we work with the glass industry and the glass build-up. We work with the blind industry and the coatings and they use, and then of course with the mechanical or ventilation system. So it's actually a very complex system, and currently we see that it's not sort of fully integrated, because who's sort of fully responsible how for this system will work. We think it's a very interesting system in terms of, we don't believe in double skin facades. We think it's too complicated, it's too expensive, the maintenance is too expensive, and we don't think that would be the future. So seen from our perspective, we're still back to triple glazed units, and then we have to exercise how we can work with some simple solar shading, and still being able to integrate it into our architecture. Another feature that makes this a big challenge, and maybe some of you here can help us with this. We have these sort of folding doors, 10 meter wide and 3 meter tall. So basically 2 glass panes of 10.1.5. No, it's actually 4 meter tall. So it's 10.2 meter glass panes that we want to integrate into those folding doors. And then again, why the struggle? Because we strongly believe in the possibility of being able to open up, so the people working in the building can easily access. You very often see sort of roof terraces and balconies, but if they're not easily accessible, no one will actually use them. So the idea is that during summertime, these huge folding doors will basically open up. Of course, the wind conditions need to be okay, but basically you can open up these doors, and then you can use the roof terraces as an integrated space of the offices. So I think this was sort of more or less it of my presentation. I hope you found it interesting.